The next topic is parallel communication interface, which is nothing but Intel 8255. Intel 8255A programmable peripheral interface, shortly referred as PPI. It provides a good example of a parallel communication interface. 8255A is mainly designed for parallel data transfer. 8255A is widely used general purpose programmable input output device. It consists of three 8-bit bidirectional IO ports, which is 24 input output lines. The 8 bits of port C can be used as individual bits or grouped in two 4-bit ports, namely port C upper and port C lower. This 8255 primarily can be programmed in two basic modes, namely BSR mode, that is bit set reset mode, and IO mode. The BSR mode is used to set or reset the bits in the port C, and in the IO mode is further divided into three modes, namely mode 0, mode 1 and mode 2. Figure shows the pin diagram of 8255. It is a 40 pin IC, so all the pins are represented here: port A, port B, port C. Apart from that, read bar, write bar signals, ground signal, reset signal, chip select signal and VCC signals are available. 8 pins are available in port A, like that of port B and port C. So 24 pins, along with that 6 additional pins that constitute pin diagram of 8255. In short, data bus, chip select, reset, A0, A1, read bar, write bar, VCC, ground, and different ports, namely port A 0 to port A7, that is 8 bits of port A. Similarly, port B, PB0 to PB7, port C lower, port C upper. Port C upper means port C4 to C7, port C lower means PC0 to PC3. 8255 programmable interface, input output. As I already told, it has 24 input output lines which may be individually programmed, and two groups of input output pins named as group A and group B. In group A, port A and port C upper. Group B is called as port B and port C lower. And three ports are available. Each port has 8 bit. As I already told, port A, port B, port C. Port A and port B starting from 0 to 7. Port C similarly 0 to 7, but port C upper and port C lower. Port C lower means PC 0 to 3, port C upper PC 4 to 7. And D0 to D7 data input output lines, chip select, CS bar, reset pin, read bar, write bar, all the pins are available. And in the control logic, CS bar, that is chip select signal, it is a low on this pin enables the communication between the microprocessor and 8255A. A0 and A1 specifies any one of the two input output ports. For example, CS is the chip select signal, which is active low signal, so that the bar is there, CS bar. If it is 0, 8255 is selected. If CS bar is 1, then 8255 is not selected. So CS bar should be 0, and then based on the conditions of A0 and A1, which port is selected. For example, if the combination of A0 and A1 is 0, 0, then port A is selected. If it is 0, 1, port B is selected. 1, 0, port C is selected. If it is double 1, control register is selected. As I already told, if the chip select is 1, Then regardless of the A0 and A1 state, it is A255 is not selected. And diagram shows the block diagram of 8255A, which consists of data bus buffer, read write control logic, group A control, group B control. Group A control, which controls group A, that is port A and port C upper. Group B controls the group B and port C lower. As I already stated, it has 40 pins of 4 parts. As I stated now, data bus buffer, read write control logic, group E, group B control, port ABC. And data bus buffer, it is a tri-state bidirectional buffer which is used to interface the 8255 PPI to the system data bus, and the data is transmitted or received by the buffer on execution of input or output instruction by the microprocessor. Read write control logic, the function of this is to control the internal operation of the device, to control the transfer of data and the control or status words, control word or status words. It has some of the important pins, that is chip select CS bar, read bar, write bar, reset, A0 and A1, which is nothing but address pins. Group A and Group B controls. These blocks receive the control from the microprocessor and issues commands to their respective ports. Group A control block controls the port A and port C upper, while Group B control port B and port C lower. Port A, it has 8-bit latched buffer and output, which has mode 0, mode 1 and mode 2. 3 operating modes it has. And port B can be programmed in mode 0 and mode 1. Port C can be programmed in mode 0. The modes of operations of 8255 has two different operating modes, namely bit set reset mode and input output mode. Bit set reset mode is used to either set or reset the bits in port C, whereas IO mode has mode 0, mode 1 and mode 2, which is nothing but simple input output, handshake mode, bidirectional data transfer. BSR mode, as we can see, the control register is given here, start from D0 to D7. Whether the bit is set or reset, which is defined in D0 bit, and D1, D2, D3 are the bit select flags, and D4, D5, D6, which is don't care condition, it nowhere relates to the control word of the BSR mode, and D7 should be 0 for the BSR mode. And this shows the different combinations of the B1, B2, B3, how the port C is selected. Based on the combination of 0, 0, 0 up to 111, the port C PC0 to PC7 is selected. And IO mode, mode 0, mode 1, mode 2. Based on the control word format, we can see D0, D1, D2 are grouped as group B, while D3, D4, D5 and D6 forms group A, whereas D7 should be 1 for IO mode. In the group B, D0 is port C lower, D1 is port B and D2 is the mode selection, whether it is mode 0 or mode 1. Similarly, in group A, the D3 is port C upper, either 1 or 0, and D4 is port A, whether input or output. Input is 1, output means 0. And in the D5 and D6, the mode selection, which mode it is operating, defined by mode 0, mode 1, mode 2, based on the combination of D5 and D6 as 0, 0, 0, 1, 1 int don't care. In IO mode, as I already told, mode 0, mode 1, mode 2. And the important thing is handshaking, the process by which two devices initiate communications. Handshaking begins when one device sends a message to another device indicating that it wants to establish a communication channel. The two devices then send several messages back and forth that enable them to agree on a communications protocol. That is a mode 1 operation. We can see in the diagram microprocessor and the input device keyboard. Similarly, microprocessor is connected to the output device, for example printer. That is bidirectional data transfer. And basics of serial communication. As we can see, the transmitter and the receiver should be there to establish any communication. Serial transfer and parallel transfer. How the data is being transmitted, based on that it is classified. You can see the example for the transmitter and the receiver, how the data are transmitted and received. Anyone know that basic transmission modes are simplex mode of communication and a duplex mode of communication. One-way communication is simplex and two-way communication is called as duplex. And further it is classified into half duplex, full duplex mode of communication. Thank you.